The diagram shows the three lowest energy levels for an atom. The energy levels have been drawn to scale, so we have three different energy levels here of our atom, 2, 1, and 0. Transitions of electrons between these energy levels produce photons of the following frequencies. What is the difference in energy between the ground state and energy level 1? Okay, so when an atom de-excites, when it goes from one level to another, let's say it drops from energy level 2 to 1. Whatever the difference in these two energy levels would be, that would be the energy of the photon that's released in that de-excitation. So atomic de-excitations release photons. The photons have an energy equal to the difference between the two levels that the atom moves from and to. So let's match up these transitions to the three photons that we have over here. We can see from the numbers that they're going up in size. This is the smallest, this is the second largest, this is the third largest. Don't forget the powers, 10 to the power of 14, that makes this the smallest. These two have power of 15, and then this number is higher than the one before it. So if this is the highest frequency that we have, if we think about the equation E is equal to HF, a higher frequency photon means a higher energy photon. The diagram that we have above is drawn to scale, so that means that this photon was released from the biggest energy level transition that we can see on the diagram, which actually is 2 to 0. So there's three possible de-excitations. There's 2 to 0, which is the biggest. There's 1 to 0, which is the second biggest. And then there is 2 to 1, which is the smallest. So then, if we write down the transitions on the right-hand side of these three photons, the largest frequency photon corresponds to the de-excitation going from 2 to 0, level 2 to level 0. The second largest photon would be from 1 to 0, and the smallest photon at the top would be from 2 to 1. The question is asking us to work out the difference in energy between ground state and energy level 1. So if we look at the second photon that we have, which corresponds to the de-excitation from level 1 to 0, if we work out the energy of that photon, so if we do 6.63 times 10 to the minus 34, so Planck's constant, multiplied by this frequency of 2.46 times 10 to the 15, that gives us 1.63 times 10 to the minus 18 joules. That's the energy of the photon that gets released when going from level 1 to 0, and therefore it must be the difference between these two energy levels. So our answer would be C.